this example, we will create a 3-layer composite plate using different material properties. So for each layer, the layers will consist of fiber material and matrix material. So the first step in this composite analysis is to create the geometry. So we will start by defining a rectangular surface with dimensions of 1 meter in length and 0.5 meter in width. This surface will be extruded to a height of 0.01 meter to form the three-dimensional volume of composite plate. To create the layered structure, we will then divide this volume into 3 equal layers, each representing different material properties. So once the geometry is created, the next step is meshing. So we will generate a quad mesh to divide the composite plate into smaller elements. So we will set an approximate element size of 0.01, and the next step is to assign the material properties for each layer of the composite plate. So we will create 3 distinct materials: fiber material with the Young's modulus of 100 gigapascal and a Poisson's ratio of 0.25 for the layer 1, and matrix material with the Young's modulus of 3 gigapascal and Poisson's ratio of 0.35, and fiber material for layer 3 with the same material properties as layer 1. And moving on to the fourth step, we will apply the boundary conditions necessary for the analysis. So we will fix the bottom edge of the plate to restrict any displacement. So this will act as a rigid surface, and next we will apply a pressure load of 1 megapascal on the top face of the plate. And after setting up the model, we will proceed to the fifth step, where we initiate calculation process. So now we will move to the Fidesys preprocessor. Now to create the geometry in the Fidesys preprocessor, from the command panel, select Manage Geometry, Manage Surfaces, select Rectangle, enter length of 1 meter and width of 0.5, click Apply. Now the surface is created, which will serve as the base for our composite plate. Next step is to add the thickness to the plate. So select Modify Surfaces, then from the list select Thicken. So select the surface created in the previous step and enter depth of 0.01 meter. Now this action extrudes the surface. Next step is to divide the plate into layers using web cutting operations. Now go to the volumes and choose web cutting operations. Now select coordinate plane as the cutting option. Now select the volume. Now for the first offset value, enter 0.0033 and change this plane to XY, then click Apply. And select the volume and For the second offset value, enter 0.0066 and click apply. So this will split the composite plate into 3 layers. Now to generate the mesh, open the mesh management settings, navigate to manage volumes, set intervals and sizes. Under intervals and sizes, select approximate size and right click and select all to apply the settings to the entire model. Enter 0.01 as the approximate element size, then click apply size. Next, navigate to specify meshing schemes. Choose map as the meshing scheme. Once again, select all to apply scheme to entire model and click mesh to generate. Continue meshing and the mesh is created. In the third step, we will assign material properties to represent the fiber and matrix layers in the composite structure. Open material settings and select manage materials on the command panel. Now create the first material and name it as fiber material. And drag the hook material. Set Young's modulus to 1p plus 11 and set Poisson's ratio to 0.25. Now create the second material and name it as matrix material. Now drag the hook material and set Young's modulus to 3e plus 9 and Poisson's ratio to 0.35. Click apply to save these materials. Then close this window. Navigate to blocks mode. Select blocks. Click on add to create a new block. Select the first and third volume. To create a block for the fiber layer, click apply. Now create second block for the middle volume. To represent the matrix layer, click apply to save the block configuration. Now click the second step to assign material to each block. Select block 1 and select material matrix by selecting it from the list and then click apply. Next, select block 2 and select matrix material and click apply. Next, we need to assign the boundary conditions for our model. Select the boundary conditions. Then navigate to the displacement option. Then select create. Now we need to fix the bottom surface. To do this, I will select all the curves from the bottom surface of the model. So select entity list to be selected as curve. Then select all the curves. By holding shift key, select all the curves. Once all the edges are highlighted, I will select fix all and set the degrees of value to 0 and click apply to confirm the settings. Next, I will navigate to the pressure section in the boundary conditions menu. Here select create. I will select the top surface of the model. I will set, so I'll select this surface. I will set load of 1E plus 6 Pascal. Finally click apply button to finalize the pressure boundary condition. So you can just drag this properties panel. Now you can also check all the boundary conditions applied in this properties page. So if I select boundary conditions, then loads and select pressure, so you can see the value of the pressure applied. Now I'll select the restraints and select displacement, and you can check here. Now let's move on to the last step, calculation settings. First I will navigate to the calculation settings. So in this menu I will select the effective properties calculation. Next I will choose the general settings option. Here I'll set the dimension to 3D and select periodic. Then I will choose elasticity and then click apply. So after making these selections, I will click the apply button. So before starting the calculation, we will move on to the next step, solver settings. So I will select the method to direct and set the whichever iteration to auto and click apply. Now before starting the calculation, it's essential to save the file to avoid losing any progress. So I will select file and save as before starting the calculation. So now I have saved the file. Now click on start calculation and save it. So the calculation will run here, so this will take time. So you can check in the command line. So we got a warning here that elasticity matrix is not symmetric and it is not positively defined. So we'll check here. So if I select process data and I am getting the same error. So this error is because we have not applied this material properties correctly, or due to the overlapping of the surfaces might be the reason. So close this window So next we need to recheck this model again. So go to this manage geometry and click on imprint and merge volumes. So before that we need to delete the mesh. Select mesh and select delete the mesh and right click and select all and then click apply. So you can see that the mesh is deleted for the volumes. Now go to the geometry, then select manage volumes and from this select imprint and merge volumes, then right click and select all, then click apply. So two pairs of surfaces has been consolidated. Now next we need to generate the mesh. So select mesh and then select all, then click mesh, continue. So now we will calculate this again, apply, start calculation, then save the file, click yes. So this takes a while. So this time we didn't get any error, so that means we have done correctly. So we have took this as 3 layers, so we didn't apply any merge volumes, and that's what it is not able to apply the material properties correctly. So after merging and doing imprint to the volumes, we got this analysis correctly. So we can check these values here and set the elastic properties type to orthotropic and click on process data. So you can check this orthotropic materials. So we can export this material now. So click on export material and click and set the material name as material, file name something m. Now export this material. So you can check here the material has been exported. Now here if I check, click on manage materials and select this, you can check that the material has been added to the material management section. So you can see all the values for shear modulus and Young's modulus. So click this close button. So this is how we'll do this analysis, and this is the end of this video.